So 4 factorial is 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. So the 4 factorial is 24. So we're going to write a function that would calculate this for us. So I'm going to write the header, start with the header. So it's going to be public static. What is it going to return? What's the return value? Always integer. So it's going to be integer because whatever the result is, we're returning that value, right? So if you do 3 factorial, the return is an integer. So integer, and name of the function, we can call that factorial, something like that. And what's the parameter? What could be the parameter? Integer. So it's going to be integer. So we're going to do int and call that n, or you can call that x, anything that you want, and open and close. Just to get rid of that red lines, I'm just going to do return 0. What 2 things you actually need for recursive function that we talked about on Tuesday? What 2 things we actually need? Base case, we need a base case, and what else? So base case and a condition, and you need a recursive case. So you need a base branch and a recursive one that calls itself exactly. So we need base case that stops the recursion. So this stops the recursion, and then you need recursive case. So what would be the base case? When should we stop? So remember, we're going to be changing the value of n. This is n, right? So first time it's going to run, it's going to be n is going to be 4, and then n is going to be 3, n is going to be 2, n is going to be 1. When should it stop? Or better yet, if you can't figure out the base case, that's fine. You don't always have to start with the base case. What is the recursive case? And then it becomes negative. So when the input value becomes negative, oh, is it negative? Yeah, so a factorial 0, I think it's 1. Yeah, I think it's 1, but we're actually not going to do factorial of 0. We'll stick with 1. 1 would be the bottom line. So we won't do any negative numbers. We'll just do the positive numbers. So what would be the recursive case? Remember, where n is the value that's coming in, and then we need to do n times n minus 1, and then we need to do times n minus 2, and then we need to keep going until we get to 1, right? So when we get to 1, that's when we need to stop. We don't know what the value of n is going to be. It could be 100, it could be 2, it could be 5, but we don't know how it's going to be. So we need to keep going until we get to 1. Do we do n minus minus after the math? What do you mean after the math? N minus minus. No, I don't think we need to do n minus minus. If you just do n minus 1, that would work. So if you do turn n, which is the actual value that's coming in, and then we do n minus 1, and if you call recursion on n minus 1, that would just set the recursive case, right? So every time it's going to multiply it together, but you need to call this on n minus 1. So it'll be factorial n minus 1. So every time reducing the value of n by 1, which is what's happening here. So every time you write a recursive function, you need to figure out how is it decreasing the value? What's the pattern? So pattern here is the value of n is decreasing by 1 every single time, right? So you have 4 times 3 times 2 times 1. So you need to figure out how can we get to the base case. We don't care what the value of n is, but we do know it's decreasing by 1 every single time. Every single time we multiply. It's multiplied by n, but it's decreasing every single time. So what's going to happen is 5 is going to come in here, n would equals to 5. And then 5 would get plugged in here. Then it's not going to know what this is, right? So it's going to try to multiply it together, but we don't know what this is. So it's going to go to the next level and do n equals to 4. Then 4 would get plugged in here 4 times. Then we have an unknown again, right? So we have factorial again with n minus 1. So we would do n equals to 3. So we're going to keep going down the list until we get to what value? Yeah, it's kind of like a loop without a loop. Yeah. So you're calling the same function again and again and again, and every time you pass the value to that function, you're doing something with the value. And the idea here is you're going to be able to stop that recursion. So if you don't have the base case, then this will return forever. What would be the base case? So now we start with 5, then we go to 4, then 3, then we're going to keep going calling this recursion until when? When n equals 1, we return 1. So we do if n equals 1, n equals 1, that means we're at the last value that we are looking for. So the last value is going to be 1, n equals to 1. That's when we should stop recursion. And what should we do? We need to return 1. Why are we returning 1? To like value 3. So now n is coming in, n is equals to 3. So now 3 gets plugged in here. So this would be the base case, and then else would be the recursive case. Let me put this in a gamma function to deal with this. I'm not really sure what you mean, Raymond. What if the integer passed in is a negative? Shouldn't we have a branch to handle that? Yes. So we could right now I'm just doing like 2 cases, but yes, if it's a negative or if it's a 0, we should have a case to catch that as well. But for right now, for simplicity, I'm just going to stick with that. Well, after we understand how this is working, we'll go ahead and add the other function, other cases, the negative case and the 0 case. So right now we're just assuming that the user is only going to pass positive numbers. All right, so now 3 is coming in, 3 gets plugged in, then we'd have 3 times whatever this value is. We don't know what that value is, so we're going to call recursion. And we call recursion with n equals 2. So 2 comes in here, then 2 gets plugged in, so we get 2 times. It's not equals to 1, so we don't go in the if statement. And then we do 2 times factorial again. What value? 2 minus 1. So now we need to solve this equation. We don't know. This is the unknown. So we're going to call recursion again with n equals 2, 1. When we call n equals to 1, we get in here, we return 1, we return 1 back to this, 1 gets plugged in, 2 times 1 is 2, that gets returned right there, and 2 gets plugged in here, 3 times 2, and now we just return whatever the actual value is. In this case, it's going to be 3 times 2, so we should get 6. So if you set this to any other number, that wouldn't work, right? So if you have a 0 or you have a 2 here, then this, when n is equals to 1, that would actually give you the wrong answer all the way up, because we're going to carry that value all the way up. And that would actually give you the wrong answer. So when it's 1, we return 1. Or we can just return n, because at that point, n is 1. But n, because when n equals to 1, n is 1, so we can just return that. So let's test it out so we actually get the same answer. So I'm going to do system.out.println, and then we do factorial, and we're going to pass in 3, see what we get. And we do get 6. And the 4 should get 24, so let's try 4. If you don't know what's going on in the background, what you can do is you can write print statements and figure out what's going on at each level. So you can do what's happening here is n, the value of n, and here we can do recursive case, n equals 2, whatever the value of n is. And now if you run it, you'll see how many times that each of those print statements would run. So the first time the n is 4, then it's 3, then it's 2, and then when it gets to the base case, it returns 1. It's kind of like a loop in a sense that it keeps running until you have something to stop it, and what stops it is the base case. And every time you pass in the parameter for the factor or any recursive function, you got to make sure that parameter, it's changing the value of whatever you're passing in. So it's either increasing it or decreasing it. And in your base case, you're actually able to catch that and stops it. Otherwise, you'll have a recursive function that'll go on forever if your base case and your parameter that you're passing in doesn't actually make sense. So whatever you're passing in has to match the base case, make sure. So I can't actually do when n equals to 100. What if the user passes in 5? This case will run forever because it'll never get to 100. All right, so now we can add cases for negative and 0 value. So if it's 0, what should we do? If it's 0, n equals to 0. I think if it's 0, the factorial of 0 is just 1, I believe. So we can just do return 1. And we don't even need to check anything else. And we can do else if for the negative number. So if n is less than 0, what should we do for the negative number? Can you have a case for negative number. I actually don't even know how negative numbers would work. So let me look that up. Negative number in factorial. I don't really, I actually have never coded the negative numbers. Don't know. I'll look that up. We can maybe work on it later, to next week or something. How that's gonna work, but I actually don't know. I'm sorry. So for right now, we'll just stick with this negative numbers. For 0, we'll do this. We'll save the negative numbers for later, but for right now, we'll keep it simple. So everybody actually understand how this is working. So in this one, which one is the base case and which one is the recursive case? So we have 3 cases, right? I gave one away. So this is the base case. There are 2 base cases. Yep. So base case. This is also a base case. We will never get to this base case if you're doing recursion, right? So this would be the first thing we check, and I don't think we'll ever get to this if you're running recursion. We only get to this if the user passes in 0. Base case, and this is the